The Sun, our star. Revered by each and every civilization throughout centuries of our history, it is vital for the emergence of life on Earth and has a special significance for the human race. Since the dawn of their existence, human beings have tried to explain the hidden mysteries of this neighboring star and to influence its activity through different rites and beliefs from both mythology and religion. The Sun is our source of heat and energy. In just 1 second, it generates more energy than the whole of humankind has utilized in all of its history. Its surface and atmosphere change constantly, often emitting violent solar storms and currents of radiation, which reach the Earth at enormous speeds. On its surface, solar spots appear periodically, and its immense magnetic field extends throughout the entire solar system. In view of its considerable influence on humanity's life and future, in recent centuries, science has taken prominence by successfully solving some unclear questions. Discovering the Sun's secrets is not only our right, but also our obligation as a species if we wish to survive. On the 6th of October 1990, Ulysses was launched from Cape Canaveral, an unmanned space probe whose objective consisted in studying the Sun and the heliosphere, not only in the ecliptic plane, but also in high latitudes. Its scientific instrumentation allowed it to take samples from both the polar regions of the Sun at 5 astronomical units and from the planet Jupiter's environment. It was a combined mission between the European Space Agency and NASA. It was expected to last 5 years, yet it was in orbit for almost 20. The Solar and Heliospheric Observatory, known as SOHO, is also a combined project between these two agencies. It studies the Sun from its core to its external atmosphere, the corona and also the solar wind. A continuous flux of electrons and protons from the Sun that fills the entire solar system at supersonic speeds, extending beyond 100 astronomical units and resulting in the heliosphere. Launched on the 2nd of December 1995, the satellite is located in a privileged spot called the Lagrange L1 point between the Earth and the Sun, 1.5 million kilometers from our planet. There, SOHO enjoys an uninterrupted view of our star. Originally designed for a 2-year mission, its several extensions allowed the study of solar cycle from the 22nd to the 24th in its 2 decades of discoveries. SOHO is, therefore, the longest space shuttle mission dedicated to the observation of the Sun, also contributing with new information on solar wind dynamics. Currently, it continues to function, and its chronograph is unique in allowing us to continuously observe the solar corona. The Space Research Group of the University of Alcalá played a leading role in this mission since it developed the Central Data Processing Unit of SOHO's Energy Particle Instrument, called CEPAC. In the next few years, the launching of the SolarOrbiter, the space probe, is expected. Its main objective is to study in detail some of the most important parts of the Sun, such as its interior heliosphere and its innermost and unexplored regions of our solar system, in order to better understand and even to predict the behavior of our star. It will be the first satellite to offer close-up views of the polar regions of this star. Unlike Ulysses, it will be equipped with telescopes as well as in-situ instruments. This makes SolarOrbiter the space mission with the most complete set of scientific instruments for studying our star and its environment ever to be launched. Launch will take place at the Kennedy Space Center in Florida. The satellite will be transported in a vehicle provided by NASA, and it will take approximately 2 years to reach its final orbit around the Sun. If every prospect is fulfilled, the mission will provide extremely important data about our star for the next 7 years.